So how do you decide what data to collect? You must have a question that you want to answer, and you also need to have a hunch about what the answer is. For example, suppose your computer won't turn on. Your question is why? Now you notice that the power light isn't on and you can't hear the fan inside whirring. So your first hunch, we'll call it your first hypothesis, might be maybe my computer isn't plugged in. So you take a look, and the plug is where it should be. And that means that your first hypothesis must have been wrong. So you need a new hypothesis. Maybe the outlet is bad. So try plugging a lamp into the same outlet and see whether or not the lamp lights up. Suppose that it does. Then that means that your hypothesis that the outlet was bad wasn't correct either. You need yet another hypothesis. So maybe the computer's power supply needs to be replaced. You'll have to replace the power supply and then see if that fixes the problem. And you go on and on with this, making and testing new hypotheses until you find one that solves your problem. If you're good at fixing things, you're good at coming up with hypotheses. A medical diagnosis is a hypothesis. A good doctor or surgeon will certainly test the hypothesis somehow. Now, we can refine our idea of what an experiment is now that we know about hypotheses. An experiment is a test of a hypothesis under controlled conditions. Notice that when we had an experiment that did not confirm the hypothesis, we had to throw the old hypothesis away and try a new one. So the whole thing is a cycle, and this is how science is done.